Does anyone have questions? Anybody else, real quick before I forget? Some more people just came in. Hopefully you can find a seat. Does anyone still need this worksheet from last time? Anybody else not have it? We finished this last time. Do you need one? Anybody else need this? What's up?
I have 2 appointments.
What?
I have 2 appointments. One for my blood work and one with the dentist. And it's the third one. So I
Okay.
have to
Yeah. Do what you got to.
All right.
Okay.
Thank you.
Sure. Oh, here. This is something we'll work on today.
All right.
Hey. All right, guys. So we finished this one last time. If you were not here, then your teacher puts videos up of the lecture, so you can catch that. We talked about what the second derivative means, how to incorporate that in the pictures we make. We can have a very funky but elegant looking things like this. Okay, so we also did section 4.2 because I had skipped it at first. I even forgot what the hell was in. Oh yeah, that was mean value theorem. So we could do an example of that if you want first. Yes? I think we did one example, but I could take one out of the book here. Sure. Oh yeah, that'll give a nice funky answer. Let's see. So, a little example of the move to the mean value there. Move to, okay. So if I have this function and I know I'm going from 0 to 2. What they want me to find is a location, at least one location between 0 and 2 that has the same slope as you would if you just went from the first point to the last point straight. You all agree with me that this point, this function does not just go in a straight line. You guys with me? Okay. So how do I do this? So this is all about finding a place where the what is the same as the what. Slope, it's all about slope, correct? And we have 2 ways to find slope. We have algebraic way if I have 2 points, and the one whole half of this idea is if I went straight from the beginning to the end, what's the slope? That's freaking algebra. And of course, what do we know now? All of us advanced people. We now know how to get the slope a different way. Derivative, a lot. So let's do calculus way and algebra way. So what's the derivative?
3x squared minus 1.
That's insane. And to do the algebra way, I need 2 points. Can you guys see how to get to 2 points? What does 0, 2 up there mean? That's what is doing. What's 0, 2? Yeah, so the x is doing, yes? So the x starts at 0, ends at 2. So what are the 2 points for the endpoints of this piece of the function? So it's going to start somewhere and go somewhere. Yes? So how to figure out the 2 points? 1 point will be a beautiful point, 0, 0. And the other point will be 2, 6. So the calculus way to get the slope everywhere is this. The algebraic way to get the slope between those 2 points is beautiful. How to get the slope between those 2 points? Yeah.
y2 minus y1 over x2 minus x1.
Woohoo! Yes? I really want this to make so much sense, it's silly. I have two ways to find the slope. We've seen in the past where we find the slope two different ways and we set them equal. We've done that in the past for different reasons. This is very specifically, I want the slope of where I am on the function to be the same as the slope of as the crow flies. You guys have all heard that phrase, yes? Did I say it last time? Like, yeah, I heard it from you that one time, okay. So what do I do with f prime of x and 3? What do I do with those? Set them equal to each other, because that's the whole idea, right? I want to find the point on the graph that has the same slope as just going straight. Mathematically, just take those two things and set them equal to each other, right? Okay. And how I solve that thing? Add 1. Divide by 3. Take a square root. If I put a square root, I've got to put a plus or minus. We'll talk about it in a minute. Some of you guys might realize, what's the square root of 4? Hell shit. What's the square root of 3? I don't know. Okay. Why can't I just circle those and keep going? Oh yeah, you can rationalize it. I don't give a shit about that. But you're right, you're right. Yes. What interval are we living on in this problem? Oh, living on. Yeah, 0 to 2. So which one of these is valid? And here, there you go. Rationalize that bad boy, yes. Real quick, is everybody cool? This is obviously positive, yes? So it's above 0. And it's obviously less than 2, because it's 2 divided by something bigger than 1. So it's in between 0 and 2, yes? Just make sure when you're doing your work, you're going to get these funky little, like, square root of 11 over 7. You know, like, is that? What is that? Just plug it in the calculator. Make sure it actually is in your interval, yes? Okay, maybe? Screw you, Jeff? It is possible to get more than one valid answer, because if I have a function that does this and does this, it could have multiple places where it has the same slope. So all the mean value theorem says it's got to have at least one if it's continuous and differentiable. So if I was really smart and a good teacher, I would have said, is this continuous and differentiable? Why is that a silly question? What kind of function is it? Polynomial. Sorry, it's hard for me to focus. So it's polynomial. So those polynomials kick ass. They are continuous, differentiable, everyday aware. Yes? Okay. So be careful. I'm going to ask you like an MVT problem. Might say, show why you could apply MVT here, or show why you can't. You with me? So if the function had been this on this interval, why is that a problem? Why will mean value theorem not necessarily work? Where is it not continuous? At 1, it's also discontinuous at -1, but who cares? It's discontinuous at 1. Why is that an issue? That's in my interval. In order for the mean value theorem's conclusion to be necessarily true, your function has to be continuous and differentiable on the interval that we're given. If it isn't, then it has all these ways to escape with the mean value. If I'm allowed to teleport, I can do all kinds of weird. If I'm allowed to make a little cusp thing, I don't have to make a parallel thing. Do you guys follow? So mean value theorem is kind of very cut and dry, but it's that way because it has so many restrictions. The function must be nice in every way possible, and then that makes the result clean. Okay, I guess some of you guys look sick to your stomach. I'm sorry. I felt okay when I came in. Yes.
Can we use MBT to show that an equation has exactly one root?
Yes. Oh, sorry. that was that one, were you working on that one?
Yeah.
Which one is that?
4.2, Number 24.
Yes, okay, so what's it mean to have exactly one solution? In this case, so what's your function that you're working with in number 24? What's the function you're working with? X cubed plus e to the x. What is that problem saying it wants to happen with that function? It wants that function to be zero. Now, it's kind of, they could have given us the function and said, show that this has exactly one real zero, one real intercept, yes? But they gave it to us in an equation. All right, let me see if you guys are cool with this. The function we're dealing with is x cubed plus e to the x. That's obviously continuous and differentiable because it's got a polynomial and it's got the best function that ever existed, freaking e, dude. Yes? They're both cool everywhere. You with me? You with me? In order for this to have only one solution, it could only go through the x-axis how many times? Once. If it goes through more than once, it's screwed, correct? So, let me see how I can say this. If you have a function, how do I say this? Let me think. If you have a function whose slope is always positive or negative, for example, just to start thinking about this. If this function has a slope that's always positive, for example, let's just say positive, could that go through the x-axis more than once? No, do you guys agree? Because the only way you go through more than once is if you turn. What happens when you turn, your slope goes from one thing to the other. So if I'm going down and then I turn, it goes from negative to positive. Are you guys with me? So I don't know if you thought about that.
Yeah, for that problem, I gave it, let's say the interval is 0 to 1. And
Oh.
I tried to prove it that way.
Okay.
But I wasn't sure if I was on the right track.
So what I would automatically do right off the bat is take its derivative.
Yes.
Okay. Now think about what I just said about, let me think. In order for a function to turn, what must be true? Its derivative at some point has to be either 0 or undefined, yes, and then it can turn, yes? You can marry that with, take its derivative, and you'll notice something. What's the derivative of 24? What's the derivative of the function? 3x squared plus e to the x. What's true about both of those functions? 3x squared, considering what we just said about if the slope is always positive, all right, guys, give me feedback. Does everybody understand that if my function is always going up, it could only go through the x-axis at most once?
Yes.
If it starts above the x-axis, it ain't going through at all, because it's like, oh shit, all right, I'm going up, I'm sorry, I'm never gonna get back down. Or the other way around, if it's always going down, it's only gonna go through at most once. Okay, I like it. You take this guy's derivative and it's 3x squared plus e to the x. Is e to the x ever negative? Do you guys understand that? Because e to the x looks like this, and what's going on here? Yes, so it never exists on the other side, yes? 3x squared is at most 0, it's never negative, correct? All right, that's all I'm gonna say. I basically gave the answer, I'll solve it. Okay. Anything else from that section, if anybody tried those? Okay. So let that section, of course I had to, you've met me. I have to give you a couple like that kind of push you. They say, okay, now you know mean value theorem, let's use it in some places, yes? But the basic idea of mean value theorem is crazy nice. Get the derivative calculus way, get the derivative algebra way, set them equal to each other, right? Okay. Anything else from any homework stuff?
I have a question, but I'm trying to find it.
Okay.
It was on 4.1, I think it was 60.
60. This guy, does it look familiar? I get to take a little break. Let's see. So it wasn't 60.
Are we starting 4-4 today?
We already did. We're going to continue. Yeah, 4-4 is L'Hôpital's. The hospital. Or L'Hôpital. Nope.
What's it that one? I'll find it.
Okay, let me know when you got it.
Yes.
So, what I want to do today, I want to continue with L'Hôpital's rule. Then we're going to review graphing functions that you from precalc. So we're going to talk about like asymptotes and so forth. Yes, reminding us how to find them. So last time, if you weren't here, I did a remarkably quick, I don't know if I'd go so far as to say proof, but it is a rough proof of L'Hôpital's rule. Just to run it down very quickly, if I have the limit as x goes to something of a ratio, and it is in the form, let me say it like this, in an indeterminate form, because we're going to learn some more indeterminate forms today. So L'Hôpital's rule comes into effect when I have the limit of a ratio and it's in an indeterminate form. The one indeterminate form, well, we know two. We know two indeterminate forms, yes? 0 over 0, infinity over infinity. So today we're going to learn some new ones. Yay! That wasn't enough, Jeff. I want more. Okay, I'll give you some. L'Hôpital's rule essentially says, if this is true, and the functions have to be continuous and differentiable at A, then this is true. Jeez, what is that, Jeff? How do I say this? There we go. F prime over G prime. Yes? And if you think about it, it only makes sense. If I have a 0 over 0, and the top is going to 0 faster than the bottom is, then the limit should be 0. Does that make sense? So if I have an indeterminate form, the answer to the limit is going to be based on which piece is getting to its output quicker. So for example, do you all agree that this sequence of numbers, the top and the bottom are both going to 0? You all agree that that sequence of numbers, the top and the bottom, are both going to 0 if you keep going forever? Do you all see how the limit's going to be 0? Because the actual output is getting smaller, smaller, smaller. Are you guys kind of with me here? If they were going to 0 at roughly the same rate, then the answer might be 1/2, or 2/3, or 7, or something, right? Or E. If the bottom were going to 0 faster than the top, then the answer is going to be infinity. Okay, maybe. You guys see that? So on one level, L'Hôpital's rule, I've actually used terminology before today that alluded to the fact that the limit depended on how quickly things were going to where they're going. That should automatically tell you derivative. So you've been sort of primed to accept, oh man, that this is true. What is Henry's faculty courtesy? Oh no, it's making it worse. Oh shit. Alright, I'll stop. It's making it worse. Well, so here's a concrete example.
What you got, Jeff?
What form is that in? Bottom is 0. And
0 over 0.
the top is 0. So what form is it in? Indeterminate. Alright, so does L'Hopital, French dude, rise from his grave and say, you got used like it's freak. It's gonna happen every time you do this. He's gonna rise from his grave. Wherever you are, you can use my name. What does that mean? So when you're doing this kind of work, when you're doing this kind of problem, here's how you show work.
This is 0 over 0. That's the form it's in.
Not only are you doing this for me, you're doing this for you. Identify that you're using L'Hopitals. Yes? Otherwise, this doesn't make any damn sense what we're about to write. Is everybody cool with this? L'Hopitals you can use if it's a ratio that's in indeterminate form, 0 over 0, infinity over infinity. That's what this is. So I can apply L'Hopitals. What does L'Hopital say to do?
This limit will be the same as what?
First derivative, so cosine.
Good.
Pi.
Derivative of the top.
Derivative of the bottom.
Derivative of the bottom is
1.
1. So then what's the answer?
1 over 1.
Almost.
Pi over 1.
No. What's cosine of pi? Negative 1.
Negative
Yes?
1.
Cosine likes x. At 0 radians, x is positive. 180 degrees for pi radians, x is negative. So of course cosine is negative 1.
Negative.
Because cosine is like x, and x is negative back there. Okay, I like it. I don't know if you guys. All right, real quick. What about this one?
Limit as x. Can you make something real quick, Jeff? Sure. Okay. You can do it, buddy. Look at Jeff go. Look at him go.
You guys like difference of cubes?
Sure.
What form is that in?
Infinity.
0 over 0. Yes. Smosh. I was saying.
Oh yeah, because it's 4.
Yeah, so when you plug a 4 in, you get 16, you get 16 over 16 over 64. You get 0 over 0, correct?
Mm-hmm.
Now, look, you could factor the damn thing, and that's what we did in the past, and that would work. But I'm also now allowed to use L'Hopital's rule. Now I am. Some of you guys were using it before. It's not good, but
So this is 0 over 0. I'm allowed to use L'Hopital's rule. What's the derivative of the top? Derivative of the bottom?
3x squared.
What happens there? Actually, you can just plug in, but I mean, what happens here? An x cancels, so then you get 2 over 12, which is 1/6.
now if you factor it, you would also eventually get that. Yes? Yeah, it's a nice thing to do. Yeah. Why could I not apply L'Hopital's rule here? That's a ratio, right? Why couldn't I apply L'Hopital's rule here? What's the other thing's got to be true? Indeterminate. Is this indeterminate? No, because I can throw a 4 in. Nobody freaks out. So if you apply L'Hopital's when it's not indeterminate form, it might work. It might not. L'Hopital's like, I don't know. He can only guarantee that the derivative will maintain the answer if it's in indeterminate form. Yes. Students just sort of getting this, they're like, when we do it again, we need to keep taking derivatives until it's just numbers. No, don't.
Okay. So what about this? What you got, Jeff? Yeah, let's do this one. Yeah, this one's nice and gross.
Do you see an immediate problem if I'm talking about L'Hopital's rule and I write this? What's the immediate problem? What does L'Hopital's rule need? He needs a function that's continuous and differentiable. Okay, everybody. What's the two main things he needs given those things are true? He needs a ratio. Oh, shit. And he also needs it to be indeterminate. Okay. What form is this in? Huh?
Two.
No, it is indeterminate. It's a
two.
new
It's a
form of
product.
indeterminacy. So plug a 0 in, correct?
Now, the reason I put parentheses around this is because this is not the answer, it's just what form it's in. I'm gonna do the first half, yes, I've done half the problem, you're welcome. When x goes to 0, x goes to 0, you're welcome. What does this do? What specific way?
What does natural log look
Number.
like? Can you guys graph it in the air for me? What does a natural log look like? Well, okay. Okay. Like Jose is like, dude, let me just focus on the parts important. So natural log looks like this, yes. What's this all about?
Going to 0.
Asymptote at what? X equals 0. So as x goes to 0, I should have put a little plus sign there, I will admit. What's the output's going to? Negative infinity. Okay. Let me come at it from the right. Now, do you all agree with me that anything times infinity is infinity? If I say it like that real quick. Do you all agree that 0 times anything is 0? So what the shit is 0 times infinity?
0.
Nope. Nope.
Negative.
So, real quick, I can do the same thing I did earlier with specific numbers. If the 0 dude is going to 0 faster than the infinity dude is going to infinity, the answer will be 0. But if the infinity dude is getting there faster than the first dude's going to 0, the answers could be infinity, or it could be some finite number. Same idea as before, except why can't I use L'Hopital? It's the same idea. It depends on who's getting there faster. But why can't I use L'Hopital's? Because the stupid thing's not a fraction. I can make anything in the universe a fraction. Make 7 a fraction. Do it. Don't say 1/7, because that you changed the number. Make 7 a fraction. Do it. Let's do it again.
7/1.
Do it even better. 1 over 1/7. Right? What if I said make x a fraction where the denominator is not 1? Make x a fraction where the denominator is not 1.
X over X.
1 divided by 1 over x. Let me let that make sense. What's 1 divided by 1 over x? It's 1 times x, which is freaking x. So how do you rewrite any number as some weird fraction thing? A equals 1 over 1 over a. You're gonna love this shit. Do you all agree with me that L'Hopital's is relatively nice? If you look back to your chapter 2 homework, a lot of it goes super fast now. If you look back and you're like, bang, done, I'm done. What the shit? I already addressed this. There's no way we can teach L'Hopital's before limits, because L'Hopital's is built off of derivatives, which you need to understand limits to do. So it wasn't just being an asshole. Not just that, but definitely part of it. So I can rewrite this. So this is a new indeterminate form. That is a new form of indeterminacy. I can rewrite this as that. That is the same thing. That is the exact same thing that I wrote first. But why is L'Hopital now going to rise from his grave and say, go ahead? Because I've now put it in the form of a ratio. That's the only time. His method is hardwired on that. So if I can take something that's in indeterminate form and I can force it into a ratio. Now that is not natural. Would you just do this just for no reason? Would you just do this? Nobody would ever do this shit. But now I can apply a relatively easy method because I made it a ratio. What do I do now? Well, first off, what form is this in now? What's the top?
0%.
No, what's the top?
Negative.
Negative infinity, thank you. And when you let this go to 0, what's 1 over that do?
1 over really, really small gets 1 divided by really small gets really big. That's indeterminate. Now, on one level, I want you to understand this only makes sense. What didn't x go to 0? So what's 1 over x do? Go to frickin' infinity. Of course it does, right? So anytime you have 0 times infinity or negative infinity, doesn't matter what flavor infinity, you can take one of the pieces and make it 1 over that thing. I'm not going to make 1 over ln of x because I don't have to, and I don't want to do that derivative. I'm going to make 1 over x. It's better, yes? But you could choose the other way, and then I would worry about you. Can I do L'Hopital's rule now? Can we hold a seance and get, I don't know why I keep thinking about L'Hopital's in his grave. So if I apply L'Hopital's rule, what is the derivative of that?
1 over x.
Good. And what's the derivative of this? If you want to, you can write it like that, right?
Negative x related to.
Yes. I'm going to write like this. Is that cool? It makes me kind of sad that so many students, when you get to calculus, you're still afraid of fractions. Kind of makes me a little sad, but who invented the damn things? They do what we want to. So what does that say? Can you read that to me? Somebody. Yes, 1 over x divided by negative 1 over x squared. How do I divide fractions? How do I divide fractions?
You can negative x squared over x.
What are you doing there, Joe? Yes. So let me do this one step at a time. So the limit as x goes to 0 of 1 over x divided by negative 1 over x squared equals the limit as x goes to 0, 1 over x times negative x squared over 1. Yes? Just multiply by the reciprocal. No big deal. And then what happens? What happens?
Simplify.
True. What happens?
Negative x is 0.
One of the x's
Goes away.
cancels. And what happens when you let x go to 0 now? 0. Therefore, x must be going to 0 faster than this is going to negative infinity. Do you see that? If x is going to 0 faster than this is going to negative infinity, the whole thing is going to be 0 at the end. And that's what we got. That doesn't make sense. It's not the end of the world, but that's what this is all built on. If you realize that it is dependent on who's getting to where they're going faster, that's what's going to determine the answer. L'Hopital's rule makes nothing but sense, because what does derivative tell me? How quickly something is changing, how quickly it's getting somewhere, yes? So that's why L'Hopital's rule just makes immediate sense. Hopefully. Okay, so what about, let's see. I know one thing I want to do, but I want to make sure I don't forget something. That's straightforward. Oh yeah, good. That's the one we just did. Let's do this one. Let's pick one that's kind of freaky. Oh yeah, all right. You guys are gonna love this. Let's do, yeah, that one looks really gross. I like it. Let's do that one. Does everybody understand what's happening? As much as you wish it wasn't, do you understand what's happening? What is cotangent x? What is it doing? Where is it? It's the next one. Yes? Okay. We're old hat at this. You should know what I'm going to have to do. When I have a function in the exponent with a functional base, what do we have to do? You know this.
Chain.
I've got to take a natural. Yeah. All right. Now, real quick, before I do that, somebody help me. This is a new indeterminate form. what happens to this? What happens to the sign as x goes to 0? 1 is just 1, yes? Thank you, 1. What happens to the sign when x goes to 0? What happens? 0. And what happens to cotangent? Uh-oh. What's cotangent? Cosine over sine, yes? What happens to sine as x goes to 0 goes to 0. So what happens to cotangent? Since it's something over 0, what happens as it goes to 0? It's going to infinity. I love you guys. So, listen, if you haven't figured out how the shit I operate, and by the way, do not plug infinity in. I am writing the form this is taking. I'm not writing the way I get the answer. So one time you're allowed to write infinity in place of something. Do you agree with me that inside goes to 1? Because the other part's going to 0. Does it ever get to 1? Does sine ever get to 0 if I'm approaching 0? That's what the limit does. No, it never gets there, correct? It's really close. What is 1 to any power? 1. What is anything that's not 1 to infinity power? Infinity. Yes? You guys with me? So if you took 1.001 and you raised it to the 9,000th power, it's going to be bigger than you think. I like Jose's doing that. What you got? She's like, I don't trust you, math boy.
I did a bunch of series.
Oh, sweet. What'd you get?
8,103.
Yeah, okay. 1.0001 is close to 1, but if I raise it to a big power, it gets big, don't it? So I need you to understand, this answer is not necessarily 1. You can't just go, oh, the inside becomes 1, and 1 to any power is 1. I'm done, Jeff. Your math is easy. Try again. No, you're wrong. The inside never gets to 1. So it's never 1 to a power, ever. So then the question is, okay, if the inside never gets to 1, does it go to infinity then? I don't know. Let's find out. How the shit am I going to figure this out? Okay, so let me ask you this. Here's how I'm going to do this. The function I'm working with is this one, yes? That's the function that's inside my limit question, correct? Now, you guys know what to do. What do I do so that I can get that and make it not an exponent anymore? Think of natural log. Because what happens then?
The cotangent goes into
Cotangent comes down. Okay, so here's the idea. Somewhere in the back of your brain you should have known, and I think I said this earlier, I can't remember if somebody told me, but you know the natural log's got to come into play. It's got to, because I have a functional base and a functional power. Right? So I know natural log's going to have to come in to help me get that stupid thing down. If I can figure out what the natural log of y does as x goes to 0, all right, let me see if you guys are cool with this. Let's say that first off, let me ask you this. What if natural log of y equals 2? What's y? Does anyone know?
the same.
Yes, because what's the base of ln? E. ln is just log base e. We just gave it a special thing because we like e. So we gave it a special little ln, right? You guys remember this stuff? Some of you guys are still looking at me. Anytime I say something that you have forgotten, just go, hey man, can you take a second? Because I always see people just keep going. You'll hit something I know. No, don't let that shit happen. If you completely forgot this, just let me know. So, the base on this is e. E squared equals y. Are you guys decently cool with logarithms to know you can always rewrite a log as an exponential? So if I knew that the natural log of y was approaching 2, I would know that y is approaching e squared. Let me say that again. If I knew that the natural log of y as x goes to 0 was approaching 2, then I know that the limit of y is e squared. So if I can figure out the limit of this thing, then whatever answer I get, I just raise e to it. Does that make any sense? If I would have said 7 here, this would have been e to the 7th. If I would have said pi here, this would have been e to the pi. So if I can figure out what ln y is doing, then I just raise e to that, and that's what y is doing. Now what form is this in? What is cotangent doing again? Going to infinity. And what is natural log of 1 doing? As this goes to 0, natural log of 1 is 0. Cool. Right? Is that indeterminate form? Now we know more. We know 0 over 0, infinity over infinity, and we just talked about 0 times infinity. That is indeterminate.
Sir, can you just one step back and like explain that e thing again? Because you raise both sides
Oh.
to the e to isolate y and then multiply the other
So,
side.
okay. So, Paola, you are a hero for roughly at least 11 people. So, everybody, if I have log base 7 of w equals 3, can you tell me what w is? How would you figure out what w is? 7 to the third is w. One of my students called this the washing machine because it's going round and round. And one of my colleagues calls this a snail, and he draws a snail, and I'm like, all right, it's the same guy that does the giraffe graph for cubic, but I won't. So 7 to the third power is w, and very quickly, we don't have time to talk about logarithms. If you don't know logarithms, you should know logarithms. Go figure it out. Come to see me, go to tutors, go to this, will do something. But the answer to a log is always a power. It's the power the base needs to become the inside. Logs are stupid easy. The reason that they confuse students is we chose a damn word for the freaking functional notation. Square roots. We chose this weird little, so now you can just totally, in this, you're like, what? Log? What? What do you mean log? So I think gets in people's heads. But all logs mean, if I have log base 3 of 27, what are you asking yourself? What is it? What power does 3 need to become 27? That's the question you ask yourself, yes? And what is that? 3. 3 needs a third power to become 27. Yeah, that's all frickin' logs are. That's all they are, that's it. So the answer to every log is a power. And that's why we're able to rewrite logarithms in exponential form, because they inherently mean something exponential. So logs are weird. What's the square root of, what was the cube root of 8? Why is that easy? Because you have internalized what the symbol is asking you. You don't even, it's kind of like if you learn a new language. When you're first learning, don't you have to stop and do each word, translate as you go, yes? And then when you get further in, you're like not even doing that anymore at some point, yes? You are at that point with cube root of 8. You don't stop and go, the cube root is asking me, what does it take 3 of to multiply? No, you just know, it's 2. Log, you don't have that. Log, you're at the early stages of learning a foreign language. You have to stop and go, okay, log is asking me, what power does the base need to become the, now I know how to attack this, yes? Okay. That's like my 4-minute thing about logs. Okay. So this, the base is e, to the second power is y. Bam. Okay. So if I can figure out what the natural log of y is approaching, I can then figure out what y is doing by raising e to it. So if my answer to this is 7, the answer to the original question is e to the 7th. Yeah, okay. Now, what can we do? Is this correct for L'Hopital's? Is L'Hopital happy about this? Can you use his method? Why not? Is who to what? Need a ratio, yes. Which part do you want to force down? Hell, I don't want to put 1 over now. Oh my god. Can you imagine that derivative? No. If I force cotangent down, I could just make it become, what's the reciprocal of cotangent? No, come on. No, stop it. Cotangent. What's it related to? Cotangent is 1 over tangent, yes? That's the definition, it's a reciprocal function, correct? What's secant? 1 over cosine. S goes to C, C goes to S. You with me? Cotangent is the nice one because it tells me who it's going with. Cotangent is 1 over tangent by definition. It's the reciprocal function. Okay. So I'm not going to put that down and make it 1 over this shit. That would be horrendous for the derivative. You could. But I'm going to do the other guy because he becomes, Jeff, just a tangent.
Tangent.
Yeah.
Just said it, Jeff. I forgot, I'm sorry. You guys see that? 1 divided by tangent is cotangent. So it's not even like I'm forcing him down, I'm just rewriting cotangent as 1 over tangent. Now do I have a ratio? Let me write it
Zero
again
over
since I
zero.
decided to.
Do weird things there at the end.
Zero, zero.
Jeff, the 4's not there. Oh my god. Okay.
Now I can use L'Hopital, just to double check. The top would go to negative infinity, yes. I'm sorry, the top would go to 0, good job, Jeff. And the bottom, what's tangent of 0?
Zero.
0, so it's 0 over 0, it is indeterminate.
So then what can I do?
Use L'Hopital.
Use L'Hopital's. I'll do the derivative of the bottom. There you go, did half of it. What's the derivative of natural log of stuff? No. Oh, I see, okay, but derivative of natural log of stuff is 1 over stuff times derivative of stuff. So you can memorize the specific natural log thing, but I'm always like, why would I do that? It's just chain rule. I don't have to memorize some new thing. It's just the derivative of natural log is 1 over stuff times derivative of stuff. And what's the derivative? Oh, what's the derivative of sine 4x?
It's 4
Good, 4 cosine 4x. Where'd that 4 come from?
derivative of 4x.
Chain rule, yes. Let me write this better. The way that Paula said it first, so she's like, just do that. So then 4 cosine 4x over 1 plus sine 4x over secant squared x. Oh my god.
Can I plug a 0 in now?
Sure.
Can we?
I want to say yes, but I feel like the answer is no.
Secant is 1
Oh,
plus
no,
sine.
you're right, we can. Let's try it. What's cosine of 0?
No,
One.
1. Sorry.
So 1 times 4?
4.
That's crazy. What's sine of 0?
0.
0 plus 1. 4 divided by 1? 4. What's secant of 0?
Secant's 1 over cosine. Cosine of 0 is 1, so what's secant of 0?
1. Oh,
Secant is 1 over cosine. Cosine of 0 is 1. Secant would be 1 over 1.
So it's
1. Square?
1 over.
Now here's where people are going to make a mistake. You're going to circle that and you're going to continue. What did we didn't just answer the question.
It was e to the 4.
We answered what natural log of y is doing. So natural log of y is going to 4. What does that mean y is doing?
E to the 4.
E to the 4th. Done. Okay.
The limit that we had is going to e to the 4. So that's the trade-off. Natural log helps us out a shit ton. It takes and makes like function of x to the function of x. That's the funkiest function. I can take a damn x. Okay, I can if I do natural log. The trade-off is, oh yeah, at the end, I've got to undo that. I've got to undo that natural log that I took. But it helps me do the problem in the middle. Okay. One big mistake people are going to make, let me see if by saying this you don't, is somebody's going to do quotient rule. L'Hopital's is not, L'Hopital's by definition is derivative of the top over derivative of the bottom. But somebody's going to do the derivative of the whole thing into quotient rule and it's going to go crazy. You guys understand? Don't do that shit. We're not taking the derivative of the whole function, no. Take the ratio of the derivatives. Let it be easier than quotient rule.
4.
Okay.
I see many people with questions that aren't being vocalized. Look at just read minds.
So is the answer 4, or we're doing e to
No,
the
it's
4?
not. What is it?
E to the 4.
What goes to 4? Natural log of y goes to 4. The question was, what does y do? Yes. Y goes to e to the 4. Okay. Let me make sure I didn't miss anybody. Nope. So here, let me give you a full rundown of. Oh, there is one thing I forgot. That's right. So indeterminate forms. We have the two big ones: 0 over 0, infinity over infinity. Now we got 0 times infinity. We also have. Let me make sure I don't miss anybody. 0 to the 0, 0 to the infinity. Did they list that?
Negative.
No, not 0 to the infinity to the 0, and 1 to the infinity. Those are all indeterminate. These three would lead to logarithmic limits. You have to take the log and do the limit like we just did. What's 0 to any power? What's anything to the 0 power? So what's 0 to the 0 power? Both 0 and 1. Indeterminate. It depends on which one's getting there faster. That would lead to L'Hopital's making sense because he's looking at how quickly these things are moving. This one we did earlier. Now, if I just said what's 1 to any power, the answer is freaking 1. But this means, I should put parentheses. This means it's approaching 1. It doesn't get to 1, so that's why that's indeterminate. And that's indeterminate because it depends on which one's getting to where it's going faster. So now let's do this. Yes. Okay. Let me see how much you guys remember. Okay. Am I recording? Yes. Section 4.5 has more details. It does, it asks for like end behavior, intercepts and all. So it kind of adds on top of what the first derivative tells us, which is increasing, decreasing, local maxes and min. Second derivative, concavity, inflection points, right? Then it brings back all this other stuff. So I just want to review this stuff real quick.
Yes, sir. Can you put the other page back on? I have to read something.
Sure.
Sorry.
If I can find it. This one?
No, I just had to rewrite the indeterminate forms that you wrote out.
Oh, yeah. Where did I put those? Oh, they're there. Okay.
Sorry, just really quickly.
So, end behavior. Who remembers what end behavior is? Does that sound familiar? End behavior.
What happened?
Okay. If you had to guess, it's how something acts at the ends. End behavior, right? Not like if you're about to die, what do you do? But okay. Where'd you go? There you are. So this one, for example. So I mean, if I have something that is x squared plus other lower degree terms. Well, let me hear. Let's do a specific one. Plus 3x minus 11. Sure. When x gets really big, what term dominates? The squared term, right? So this is gonna look like a parabola. In fact, this is a parabola, but I'm just starting easy. The 3x to the minus 11, could do shit in the middle. So if I had, for example, x to the fourth, so this is gonna look like a prime problem. X to the fourth plus 5x cubed minus 7x squared plus 48 x minus 110. When x gets really, really big, if x is a trillion, do you agree a trillion cubed is pretty damn big? Times 5. But compared to a trillion to the fourth power, that ain't shit. Yes? That wouldn't be shit. This guy wouldn't even see him. So when x gets really big, this is the only term that matters. So if I have an even degree thing, the end behavior will be up on both sides. Or, if I have a negative, so this will be up on both sides. This will be down on both sides. Is this sounding familiar to anybody? Okay. So obviously if I have an odd degree, what's that gonna look like at the ends? Yeah, there you go. I like it. It was looking like you're doing like some kind of staying alive thing. Alright. So you got up, down. Yes? It looks what I call cubish. Now, real quick, do you see how I'm not connecting these? Because all these other terms become dominant when x gets small. Isn't 0.1 small? Do you all agree 0.1 cubed is really small? But it's nowhere near as small as 0.1 to the 7th power. So if I invert this and I go let x get small, these things dominate and they can make it wobble in the middle. Because they get to play if x gets small. I don't know if you guys are with me or not.
So if it's negative, it's negative.
Yes. So if I had a negative x to the 11th plus 2x minus 7, that would be like that. Just because negative out front makes it reflect. Yes? Okay. Not back on its life, but around the x-axis. Okay. Hopefully that sounds familiar. If not, you guys probably need to go get some refreshers. So can somebody tell me what the end behavior is for this guy? And why? What is the degree of that polynomial? Good, because the degree of polynomial is the highest degree. If somebody puts that out of order, they didn't just suddenly magically change how it looks. So it's a 7th degree polynomial. Is that term positive or negative? So can you draw the little disembodied arrows that show the end behavior? I love when you guys do that, because it does look like you're dance or something, like Elaine Bennis. So x to the 7th is going to be this kind of thing, right? I love when you guys do it because it looks like you are dancing. Little Saturday Night Fever going on. So I don't need a little visual is all I need. That to me makes the most sense. So you would just put here, it's got to go down over here and it's got to go up over there. So I know what this is doing at the ends. Sorry? Oh, I'm sorry.
Oh, I was about to say.
Good Lord, Jeff. I'm not gonna even try to save face. I was just totally put those in the wrong place. Yeah, I seriously thought I was switching it. Oh, this is a great sign for me.
When you changed that, I was like, I have a rock.
How do I find the intercepts?
By setting things equal to.
Sure. Okay. What would that find specifically? How do I find the intercepts?
That would be your y-intercept.
Set y to 0. So another way to say that is make the output 0. How do I find the y-intercept? Make the input 0. All right, do it. I'll wait. One of my last math classes, I had a function that had 13 variables in it. I had to find the w-intercept. So what did I do? I made all the other variables 0. This idea goes across all of mathematics. Doesn't matter how many dimensions you live in. Thankfully, we're living in 2 here. One of your answers will be gross. It's just too bad. And 2 of them, actually. How do you factor this?
You take next to the 5. 28 minus 5.
So if you make this 0, then x would be 0, and that's something we already know. Whenever one of them 0, 0, the other one has to also have a 0, 0, right? How do we get the other couple of x-intercepts? At least the real ones.
Divide 28 by 5 and square root.
We'll set that piece equal to 0. Yeah. If I set a polynomial equal to 0, I try to factor it. Set each factor equal to 0. Right? This has got to not be that big of a deal. You've done a lot of this shit. How do I make a polynomial? Or factor the damn thing, set each piece equal to 0. If I set that equal to 0, I get 0, 0. I already got that. Set this equal to 0, subtract the 28, divide by -5. Take a square root. If you take a square root, you put plus or minus. Okay. And what is 28 divided by 5 square root, roughly? Can somebody do that? Let me take a guess. It's going to be, well, square root of that. I don't know, Jeff. 2 point, what is it?
2.37.
Do it again.
2.37.
All right. Okay. Since we're doing this by hand, we can make it 2.4. Why did I have to make it so gross numbers? Well, because look down at the first derivative. Do you guys see that? Isn't that a nice first derivative? That's why I had to make the numbers gross, so I knew that the derivatives would come out nice. Something's got to give. Do you guys remember what part C means? We're talking about multiplicities, yes. Do you all know the multiplicities of each of the roots, each of the x-intercepts? What's the multiplicity of 0? Let me just do it like this. How often does 0 show up as an answer? 5 times. Kick ass. Odd number of times. So what's it going to do at 0? It's going to go through or bounce? It's going to go through. Yes. Now, I think the way I talked about it with you guys is it would change signs. What that means visually is if it's down, it's going to go through and be up. If it's up, it's going to go through and be down. If I had an even multiplicity and it stays the same sign, that means it stays on the same side. So it would turn like a parabola, which makes sense because x squared is a freaking parabola. Yeah, so it would stay on the same side it started. Maybe. So when I go to graph these, I know when I hit 0, I'm going to go through it. I'm not going to turn at 0. What about 2.4 and negative 2.4? Couldn't you factor this? Believe it or not, you could. In fact, it's easy as shit to factor this. You ready? Look, kids. How do I factor, real quick guys, how do I factor 9 minus x squared? 3 minus x? 3 plus x. How do I factor 28 minus 5x squared? The same way you just did. Same exact way. Where did 3 come from? Where did 3 come from? It's the square root of 9. Alright, so what do I put here? Square root of 28, square root of 28, minus plus, square root of 5x, square root of 5x. And do you see how that would lead to this? Like, add this, divide by rad 5, and we get this, yes? So if it's a difference of squares, it doesn't even have to be a perfect square, you can still do it. Now, what does this help? Don't do this shit. But what's the multiplicity of each? 1, good. I knew it right here, that was squared. Since I got 2 answers from a squared, I know each of them shows up once. So I don't have to do what I just did, but I wanted to show you. Look what I can do. So these show up once. So what is it gonna do at each one of these?
110.
Like we said, it's gonna go through, because it's an odd multiplicity, yes?
Even is like a parabola, it's gonna turn. Odd is like a cubic or line, it's gonna go through. Does anyone remember this? Has anyone taken precalculus? You know that course you take before calculus, at least for now. The state wants to make it so you don't have to. Sorry. Be all right. So we know the intercepts, we know the indicator, we know what they do at each root. We can make a rough sketch.
My x-intercepts are 0, 2.4, and negative 2.4. My y-intercept is 0, 0. That doesn't really help too much. I'm gonna do a very rough sketch.
Where do I start? Well, what does my corrected end behavior tell me to do? Start up here, yes? So I'm gonna start up here. You see that? Start, what am I gonna do when I hit this? Go through. I gotta turn somewhere. What am I gonna do when I hit this? Go through. Then I gotta turn somewhere, yes, because I gotta come back to this guy. And then what am I gonna do? Okay. Do you guys see? Here's a really, really rough, horrible, pathetic, shitty graph that would nowhere be good enough to give to me, but this is what we're gonna do for right now. I start up here, I go through, I turn, go through, I turn, I go through. Yay! Can you guys see naturally, if I'm careful with how I graph it, I see concavity happening, yes? If you had to guess, where do you think an inflection point is?
1, 1.
What's inflection point mean? Can you guys see? Or can you
0,
be
0.
where this happens? 0, 0, yes? Because it would go from cup down to cup up. Do you see that? So if I had to guess, I'd say there's an inflection point of 0. So can you see that? And I didn't even graph it that careful, and I didn't graph it with any of that knowledge. But you very often will get that happen, and you can see it. So you're like, you know what to expect from the calculus. Should at least be close to 0, if not 0. Yes. All right, how do you guys feel? Does anyone remember doing this? A little bit? Okay. Here. Derivative. All right, I'm gonna let you do that in your own time. But if you take the derivative, it would come out to be this. What are the critical numbers?
2 and negative 2.
Is it ever undefined? What else is a critical number?
0.
Good. Is it ever undefined? No, because this is a polynomial, there's no variables on the bottom, there's no radicals, there's none of that crap, so it's never undefined. If I wanted to, let's just do this. I know I didn't say to do this here. I'm not sure why past Jeff didn't say to do this, but we're gonna do it. You can make one of these, yes? Real quick, for the derivative, what's the multiplicity of 0? 4. And then for each 2, it's,
1.
alright, so now I know if I plug in like 80 billion, or maybe 3, what will I get? If I plug in a 3, what do I get? Positive?
Positive. Positive.
2 minus 3?
Negative.
Negative, 2 plus 3. Positive. So what is it up here?
Negative.
Negative. 0 here, 0 there, 0 there. So now I know it's going to change signs. Yes, it's an odd multiplicity. It's going to change signs. Around 0, it's going to stay the same sign. And around -2, it's going to change signs. Does that match up with what our graph looked like? What's it supposed to be doing up to -2?
Going down.
Going down. Now, see where I turned?
Positive.
Do you see how I didn't turn at the... Oh, I should have turned right here at 2. Yes, -2, sorry. But that's okay, this is a rough sketch. So it is going down until about 2 roughly. Then do you see how it's going up through 0? But what should it have actually done through 0? It should have been like a little cubic thing almost, like a... It should have been like flat for a second at 0. And then it should go down starting about right here, and now I know it's actually 2 is where it should start going down, and that's roughly where it started going down. So this thing is not what we're going to do. I wanted to see if you guys remember doing, this is how much you did in pre-calculus, and now we can get more detail from calculus to help us make a better picture. Now let's see if our prediction about where the inflection point is true, and then we'll take a break. Again, on your own time, you can double check this, right? Just take the derivative and see if it factors to be this. What are my critical numbers? So then I have to do the same thing we did earlier, right? No? I mean, you could if you want to. I don't want to. Add this over, divide by 3, take a square root, yes?
Of 8 over 3, yeah.
Let the algebra stuff be easy, yes? So I'm just trying to solve that. I can get x by itself and then take a square root, yes? And if I'm going to graph this by hand, I would just get an estimate for that from the calculator, right? You only have to go to 1 decimal place for graphing by hand. What is that? 8 divided by 3 is almost 3, so the square root's almost 1.7 something.
1.6.
1.6, yeah. So we're going to say it's roughly plus or minus 1.6. So I got 0 plus or minus 1.6. Jeff, you can do it, buddy. So the same thing again, just for the second derivative, correct? This should feel a little repetitive, but each time I do it, if I'm doing it for the first derivative, that's maxes and mins and increasing the area. If I'm doing it for the second, it's concavity and inflection points. Everything's multiplicity is 1 here. Is that cool? I got 2 answers from this, so that'll be 1 each, and I got a third power on the 0, so that's another, not multiplicity 1, but multiplicity odd. That's what you need to know. Good job. So it should change signs everywhere. So if I plug in a 2, I'll get positive times negative. Right? 3 times 2 squared is bigger than 8, so that's positive times negative. Then it changes sign everywhere. So where are their inflection points?
Negative 1.6.
Yeah, whatever, 0, 0, and then 1.6, whatever, yes? So now you can see my rough sketch from the viewpoint of calculus sucked pretty bad. Not that it sucked pretty bad, but in here somewhere, negative 1.6 should be where it changes concavity. Positive 1.6 should change concavity. I didn't know that back in pre-calc, so this was good enough for pre-calc. So let's take a break. If nobody has any immediate questions, let's take a break. Come back at 2.
do what?
I used to get the names of the characters too, but I don't know them. But I'm gonna know the names.
I did a couple of
Guys,
these.
you guys,
Yeah. Two of these were actually easier. I was just making sure that I'm understanding. Because initially what I needed to write is need to differentiate whatever whatever x is, break it down first, and then I need to find
What are we trying to find?
I'm trying to find the absolute.
Ah, okay. Those kick ass, or in the local, so the absolute kick ass. Because you get your critical numbers, your endpoints, you plug them all in, see who's biggest, who's smallest. Locals, you need to do the Sunday.
Mhm.
Yeah.
Thing is, like this one as well, this one was also out of the DM because it was gonna be 6 times 1 over x, so it's 6 times natural log of x. I'm
Wait,
actually,
what do you mean?
well, cause
No, the derivative. Are you saying that's the derivative?
yes.
No, you got it backwards. Derivative of ln of x is 1 over x. The derivative of 1 over x, write that as x to the negative 1, yes? What's the derivative of x to the negative 1? The negative 1 comes down, becomes negative 2, yes? What's the derivative of ln x?
ln x is,
What's the derivative of ln x?
that's not e, it's 1, right?
The derivative of ln x is 1 over x. You did it backwards. The derivative of 1 over x is not ln x.
This is why I'm gonna go home and just print out a sheet of all the different differentiations, as well as, what was the other one?
So, guys,
Inverse functions, I'm just gonna print those out.
End behavior. Make sure you understand what that is. Finding the intercept should not be anything new. That should involve some factoring a lot of the time, yes? Y-intercept kicks ass, you just throw a 0 in and see what happens. Why can't you have more than one y-intercept? For the kind of things we're looking at. It wouldn't be a function, yeah, there we go. And this is calculus, this is the stuff we did relatively recently, yes? And if you have any trouble verifying the derivative, just let me know. And I'll let you do that on your own time. You guys with me? Okay. So let's look at the other side. Let's see if this comes back. So the first question, the way you do it, does not give a shit what the function is. How do you always find the y-intercept? You make x0. How do you always find the x-intercept? You make y0, or the alpha 0 is another way to say it, right? Okay, go ahead and find the intercepts. Just to remind you guys, if you make the bottom 0, the function actually goes to infinity. So don't be telling me values that make the bottom 0 are intercepts. That doesn't make sense. So if you take the rational expression, rational function, and you factor it fully, you're ready to answer most of the questions that are asked. What are the x-intercepts? Yep.
Plus,
Negative 1, 0, and 1, 0. Because the only way to make this output 0 is to make the top 0, and those two values make the top 0. So x-intercepts, negative 1, 0, and 1, 0. Intercepts of points, what's the y-intercept?
2.
Yeah, make x 0 so you can literally just cover it. Make x 0, bam! That reduces to 1/2. You guys see that? You guys with it? So Somebody told me they were gonna try to do an impersonation of me, and said the one big thing was, "Are you with me? Are you with me?" I used to be going like this all the time. Maybe. I think I do that every now and again. But somebody said I'll do impersonation. Maybe. Vertical asymptotes. What the shit are those? The whole idea of a vertical asymptote is it's a wall that says, "Do not come here." Yes, I always, being the geek I am, I always think, the shield generator is still up, pull up, it's a trap, Right,
It's like it's
No, is that just me?
wall, it just goes up.
So you have to kind of slam up against it. That's the traditional thing with asymptotes, is you slam up against it. So I literally put a wall at the value of x that my function freaks out at. So what values of x does my function not exist at? So the equations of the vertical asymptotes are x equal -3, x equals 2. They are vertical lines. That's their equations. Don't just say -3 and 2, that doesn't make any sense. Now I put the little box that I give to my precalc students to interpret the 3 situations you can be in. But we already talked about these. You guys remember when we were doing limits? If the top degree is, if the bottom degree is bigger, the whole thing goes to 0, right? You remember this? No, Jeff, no, you never said Jeff, you never said. Screw you, you said. If they're the equal degrees, it's the ratio of the coefficients, yes? Ratio of the leading coefficients. We've done this before. Okay, so if you say we haven't. So what situation am I in? The degrees are
Equal.
the same. So what's the horizontal asymptote? 3 to 1, so it's 3, yes. So at the ends, you can, horizontal asymptotes are a type of indicator. As x gets big, my outputs have to approach 3. Can I go through the horizontal asymptote? Yes, you could go through it an infinite number of times. Here's an example. I could have a function that goes like this. Here's my horizontal asymptote. Do you all agree that it's getting closer to that over time? Yeah. So as long as you're getting closer to it over time, it doesn't care if you go through it. Most of the time, it won't go through, but it is completely allowed. Sometimes it'll go through and then it'll go, oh shit, and it'll come back and start to approach it. You'll see that in some functions. Are you guys at all with me? Does this sound familiar to anybody? This is a wall. It says, you cannot be here. This is a, hey, can you eventually get close to me? Yes? Okay. I don't know. Can you guys take a minute and figure those out if you haven't already? I'm gonna do it my way. It's all right. Someone's gonna tell me. I don't know. Help me out. Doing it in my head. In my head. Sorry. Can you all double check if those right? No? Okay. What's that?
I did that 7.5.
Yay! Thank you, Paul. Everybody else, I'm gonna leave you in suspense now. Hold. So I will often give you inputs to do that will help you graph. So we'll see why those were good points to do. So what do we know? We know intercepts. We know asymptotes. We know these points.
So, what scale do I have to be careful about? What's a good x scale to do for this? What's the biggest x value that you see? Yes, -4. There's -3, there's 2, there's -1, there's 0, there's -4. So going by ones is fine. What should I make my y-axis scale? Gonna make it ones also. Gonna make my y-axis scale go by ones. What's the biggest y that you see? Yeah, the biggest y I see some zeros, I see a half, I see a 3, I see a 7.5, shit! So what should I maybe make my y scale? I would go by 2s, yes. So by the way, you all know I'm an asshole. So when I teach pre-calculus, I let them know directly. I don't say this to them to scare them. I let them know pre-calculus's job is to be graphing hell. Pre-calculus's job is to make you graph the shit out of everything. Why? Because when you get to calculus, that should be second nature. You should be able to give me a rough sketch of a lot of shit. That's the one big purpose of pre-calc, is to study the hell out of graphs. So when you get here, you can focus on the calculus and not worry too much about the graphing. Okay, so what can I put down here now? I know my, let's see, for example, I know my intercepts are 1, 0, and -1, 0. I got a 0, 1/2 intercept, yes. I've got a point at -4, 7.5, and I got a point at 3, 4. I've got x, I got vertical asymptotes at -3 and 2. Holy shit, it's almost straight jump. And then I got a horizontal asymptote at 3. Okay, so what I've done there is I've made 3 regions. 1, 2, 3. So for example, in this region, it could either be this. See that? I gotta slam against that wall, yes? Or it could be this. Obviously, which one is it? There's a point there. And now you see why I had to do f of -4, so that I knew it was up here. Another thing is, if it was here, what would have to exist about right there? What would have to exist about right there? What's the only way to get through the x-axis? If there is a x-intercept. Is there an x-intercept there to let me through? So it can't be this. Do you guys see that? I didn't really even need that point because I knew it couldn't be down here because there's no x-intercept to let me in. So it must be contained up here. I'm really hoping that my voice comes back. There we go. I'm really hoping this is a review because I'm not going to teach this. This is a review. So this is going to slam up against that asymptote, slam up against that asymptote. What's it doing here? By the way, what's the multiplicity of my x-intercepts? What's the power here? What's the power here? So they both have a multiplicity of 1. So what's it going to do at each one? So it can't go like that because it's got to start here, go through. Can it come back up? Because there's no x-intercept, so it's got to do this and it's got to do that. It looks a little parabolic in the middle, yes? It's not perfectly parabolic because it's not perfectly symmetric, but you know. Are you guys with me at all? Screwing Jeff? So like the y-intercept is a huge clue as to what things are doing. And then we have the same situation on this side now. Now you see why I made you do f of 3. Because again, now I know for sure it's up here, but I actually knew already because there was no x-intercept here to let it through. I think of x-intercepts as doors. They're doors to get through that axis. There isn't any, so I must be up there. And the point tells me, yep, you're up there. So then I'm like this, slam up against that, slam up against that. Now, all of that was pre-calculus. In calculus, what would we have added to this? Concavity, right? Maxes and mins, you with me? Is that necessarily the max? In fact, it would help explain why this is so lopsided if maybe the max is over here. And then it would kind of go through better. Do you guys see that? In pre-calculus, you don't know that shit. So you just sort of go, oh, and we do the best we can. Calculus, we can now figure out what the maximum is. You make a sign diagram for the first derivative, C plus minus, blah, blah, and you know what the maximum. Then you can make a more precise picture. Okay, so that's a review of pre-calc stuff. So in section 4.5, they're going to marry concavity, inflection points, maximum, blah, blah, blah. They're going to marry that with this. Very exciting. We're all looking forward to it. I know. Okay. So, let me ask you this. What was the most difficult thing from today? What was the thing that made the least sense? Let me say it like that. Can you articulate what made the least sense? And you're like, everything after you said, welcome. You lost me at hello. Show me the math. Math. Nothing? Did everything make sense? It makes sense. What's up?
Not that it doesn't make sense, but you're seeing like something when it, which indeterminate form it is.
Oh yeah. Okay. Good. Okay. So here, let's do another example of that. Pick a nice one out. Let me see. Oh, they already did that. Shoot. Let me do here. Okay. Oh, that's right. I did forget to go back and do this. I'm glad you're asking this question, Lucky, because there was one type I didn't go back to do. Let me do this one instead. Make this 0. Now, you guys see ratios, yes? But do you see a single ratio? Nope, so L'Hopital's can't apply to it. In fact, at the moment, we don't even know if this is indeterminate. What form is this in? Put a 0, sure, but I mean, throw a 0 in. And then you're allowed to write infinity. That's the one time you're allowed to write infinity is when you're investigating the form it's in. What does this do as x goes to 0? And what does this do as x goes to 0? What's each of the 0? Minus 1? 1 over 0 goes to? Now, real quick. Somebody out there right now is thinking, well, Jeff, the answer is 0, dude. Something minus the same thing. No, but is infinity a number? It's a process. If that's going to infinity faster, then in big infinity minus small, it's going to be infinity is the answer. If that's going to infinity faster, then negative infinity will be. If they're going to infinity at about the same rate, I could get a finite number answer. It is again all about which one is going to infinity faster. Does that make any sense? So a concrete example. If the first dude is going to infinity faster, let's see, like this is a 10 minus 5, and then it becomes 100 minus 6, and then it becomes 1,000 minus 7. Do you agree with that each piece is going to infinity? You agree with me? 10, 100, 1,000, 5, 6, 7. Is each piece going to infinity? If I let that continue forever, are they each going to infinity? Good. So that is a representation of infinity minus infinity. Do you agree? Because infinity is a process, not a number. If you let that continue, that is in the form infinity minus. Well, what's the answer going to be? What's 10 minus 5? What's 100 minus 6? It's 1,000 minus 7. Are you getting bigger or smaller? And you're going to continue to get bigger, won't you? Because the thing I'm subtracting can't keep up with what it's subtracting from. So of course this dumb thing's going to go to infinity. So if the first dude is going to infinity faster than the second, the whole thing's going to infinity. Does that make physical sense? Does that make concrete sense? Just so you understand, it should. I'm not saying that you should right now understand it. I need you to, it should make concrete physical sense. Just if you're sitting there going, for this guy, sure, well, didn't know. A number that's growing faster than the number I'm subtracting from it, if I let that go forever, it's going to infinity. The second dude's not getting big enough to keep up. If I reverse that, then it's going to go to negative infinity. 5 minus 10, 6 minus 100, 7 minus 1,000, that's going to negative infinity. Okay. If they were going to infinity about the same rate, what about if I do you agree with me that, here, 10 minus 5, 11 minus 6, 12 minus 7, are these going to infinity? If you continue forever, are they going to infinity? 10, 11, 12. Continue. Okay, 5, 6, 7. Will that go to infinity if you continue? I don't care about eventually. I need you to understand real quick. 5 is as close to infinity as 50 trillion is. They are both as close to infinity because infinity ain't a damn place. It is a process. Here's infinity. Now, if I kept doing this forever, that's infinity.
It's not going anywhere. It's 5 by 5.
Good. I haven't talked about the two interacting yet. Individually, they're going to infinity. So it's a form of this, yes? Since they're both growing at the same rate, their distance stays constant. So this would actually go to 5, yes? So the answer to this could be anywhere from negative infinity to infinity. Great. So, does it now make sense that the process that relates limits to how quickly and slowly things are moving should be able to apply here? L'Hopital should come into play, because the whole thing here is what's going faster. Why can't I apply L'Hopitals? Because they don't have a single ratio. Well, I have two fractions. How do you make one fraction out of two? You make a common denominator. Darn it, someday I'll say that right. You make I gotta say it right for once. You make a common denominator. Thank you. How do I make a common denominator?
Give the other side.
Yes. So some of you guys freak out. But, I mean, what does he have on the bottom? May I ask you a weird question? The answer is no. I'm telling you right now, the answer is no. Does he have an x on the bottom? He does not have an x on the bottom. He has an e to the x minus 1. That's what he's got. He's got no x. Sort of like, do you agree with me that 1 over 8 has a 4 in there? Does it have a 5 in there? No, even though 8 is 5 plus 3. Right? So it's about a factor of x. So what does he need that he's missing? All of this shit. It's like 1/7 plus 1/5. What would the LCD be? 35, because they're each missing each other. Aw. So we give them each other and we put them together. Forever. Okay. So this guy, shut up, Jeff. So this guy needs all of his business. And this guy needs x. Do they have the same denominator?
Yes.
So I get e to the x minus 1 minus x over x times e to the x minus 1. And you're like, thank you, Jeff, that looks so much better. Do I have a single ratio now? Yes. What's the top going to? Oh, shit. E to the x is going to what as x goes to 0? E to the 0 is 1. 1 minus 1 minus 0 is 0. Yes? And what's the bottom going to as x goes to 0? It's going to frickin' 0. So is that indeterminate?
Yes.
Yes. So what am I, and now I have a single ratio. We knew it was indeterminate, we just now put it into ratio form, and we verified it's still indeterminate. So what can I do now?
I can use L'Hopital.
No. L'Hopital. Here, I'll do the top. Oof. Now you guys do the bottom. Is that cool? Derivative of x is e to the x, derivative of negative 1 is 0, derivative of negative x is negative 1.
1/8 of
Taboo. So what do you have to do on the bottom? Prodigal.
You could distribute and not do product rule, but
You still have to do your product rule, so I'm not doing product. So the derivative of x is 1 times this, plus x times the derivative of that. Is that alright? Now try to plug a 0 in. Let's see. The top is still 0. The bottom is 0! Sorry, I gotta calm down.
Go again.
So I could do L'Hopital's again. I could. You might as well. Yeah. The limit as x goes to 0. Now what's the derivative of the top?
1.
E to the x. Derivative of x, e to the x, derivative of negative 1, 0. And on the bottom I get e to the x, derivative of negative 1 is 0. Plus product rule, derivative of x times e to the x plus x times the derivative of e to the x. So now when I plug out 0 in, what do I get? E to the 0 is 1. E to the 0 is 1. E to the 0 is 1. And then 0 times who gives a shit is 0. So I get 1.
that's the power of L'Hopital's. So you can only apply L'Hopital's if you're staring at an indeterminate form. This should make complete sense. If I apply L'Hopital's once and it's not indeterminate anymore, I can determine the damn answer. Right? That's the whole. That's a beautiful way.
Literally no reason not to get that.
Yeah.
Like,
And the real key thing is, if you do L'Hopital's when it's not indeterminate, it doesn't have to stay the same limit. The process only really works for sure if it's indeterminate. So anything else from today before I do one last thing here? Anything else from today? So today we did a lot. We did, asymptotes, intercepts, and behavior, all that stuff, yes. That is supposed to be a review, but I understand maybe you took precalc during COVID. And you're like, dude, I don't remember shit from there, okay? Maybe you took precalc a long time ago. Maybe you took it recently and it's just out of your head. So you want to you gotta review. You gotta review. That's what the SISL's for. You could literally go into the SISL, log in, look at the instruction and say, dude, I need help with 4.3, 4.5, whatever. I need help with asymptotes. Can you help? And they will find shit to help you. That's why we put instructors in here, so they have a backlog of worksheets and stuff for you guys. Understand? Okay. I know some of you guys go in the SISL. It's really good. Hopefully you get a lot out of it. So I'll stop talking about the SISL. Last thing for today. If there's nothing specific. I want to see if there was another example last year. So, just a little teaser for what we're about to get into. 4.7 is not in our curriculum, so I'm sorry, 4.6 is not in our curriculum, so we're not skipping it, it's just not part of what we look at. The workshop that I have today, that I have 3 more of them coming, is all about how to set these problems up. Section 4.7, all right, let me talk about this. So I already told you guys this is the word problems again, yes? This is the second round of word problems. So, let me see if you guys agree with me or not. Related rates. The calculus was harder than setting up the function. Most of the time, that's true. 4.7, I think it turns around. The function is harder to set up than the calculus, and we'll see if you agree. 4.7 is beautiful. The thing with related rates that sucked is it was implicit. We were taking derivatives with respect to time, and there was no time variable. 4.7 is not implicit. You're explicitly doing straight up normal derivatives, so the calculus automatically will be easier. It's setting up the function is going to be harder. And the unfortunate thing is, you guys just don't get the same level of practice with modeling real world in terms of calculus. You just don't. So what I want to do real quick, let's see. If I tell you
I have a rectangle with a perimeter of 80. Can you guys represent that in equation form? So there are several things that stand in the way of you writing that as an equation. Now some of you guys memorized the perimeter form, which is great. But what do you have to identify for yourself? Do you know anything else about the rectangle besides the perimeter is 8? So how long could it be? Here, let's do this, some concrete examples. Concrete examples. What if this was, you can do it, Jeff. What if this was 30? What would this have to be? Be really careful. Well, let me just say, if that's 30, what would this length have to be?
Half of 10.
Now, real quick, I'm glad nobody said 50, because then if you're trying to contain your lions, you haven't put anything over here. You put it all here. That sucks. So that's 30. This is 30. That's 60. I got 20 left. 10, 10. Yes. So real quick, if that's the truth, if that's the way it is, what's the area of this? 300. Good. Now, can somebody give me another way I could set that up so it still has a perimeter 80? So I physically have 80 feet of fencing and I want to use all of it. But I can make my rectangle all these different shapes. So why couldn't this be 60, for example? Because I've already, I don't have that much, yeah? So can somebody give me another valid number for the length here? 20? So that's 20, this is 20, what are these? What are those? Sorry.
It would be a square.
It would be a square, what's the area? 400, right? You guys with me? Semi? No? Screw you, Jeff? Can somebody else, somebody I haven't heard from yet, give me a number that would work for down here? I want 80 total perimeter all the way around. What will work for this? Do it again?
Well, 25.
25, kick ass. Kick ass. What would these be? 25, 25 is 50. How much do I have left? So these could
15
be
and 15.
15. What would the area be? 753, 75.
375.
If you had to make a guess, do y'all understand? Each of these shapes would require me to buy the exact same amount of fencing. And if I want to put a garden in this sucker, which orientation will give me the largest area and thus the largest yield? Which shape? Now we haven't, based on what we've done, we have only investigated 3 possibilities. How many other possibilities are there? Technically an infinite number. Because you can make this side 25.789949394222. Yes, and then you can see what the others did.
So it's 2x.
But from what we've done, what seems to be making the area the biggest, if I make it a square, and that's true. If you make a 4-sided figure into a square, it causes the most area for the same amount of material. Does that sound like a good thing to know if you're a business? Shit, yeah. So, real quick, you guys know what a silo is? Not a missile silo. So, silo you can fill with
Holds
grain.
grain.
I'm a Georgia boy, so you put peanuts in that thing, or pecans. Okay. So silo is a cylinder, yes, and it sometimes has a dome top, but it's circular, yes? Why didn't they make a big frickin' square and put that shit in there? Because they figured out that they could use the same amount of material, and if they make it circular, they could fit more shit in for the same amount of material. Not shit, but peanuts. You guys coming with me? They actually knew that before the math figured that out, and then the math came along and said,
Yeah, that checks out.
yeah. So experimentally, we're like, this allows us to fit the most stuff with the same amount of material. Doesn't that make sense? So any business, the more calculus you know, the more efficient you could be.
Calculus is like the backbone of engineering, I think.
Hell yeah. Well, I mean, math's the backbone of every damn thing, but you know,
Yeah, like
certain things don't realize that.
essentially.
I might be biased.
Anyway, I'm sorry. So the main thing to realize now is, if I'm allowed to have all four sides, a square will always maximize the area. If I have a situation where, the last thing I'll talk about, and then I'll let this out nice and early. If I have a river, this might sound familiar to some of you guys, and I only need to do this many sides, right? Then the answer to maximize the area will not be a square anymore, because technically that is not a quadrilateral, because the one side's a river. Maybe I'm gonna put rabbits in there. Do rabbits swim? They probably do. Let me showcase my ignorance. Maybe I'm gonna put in there a bunch of wicked witches of the West. Because if they go in the water, they're gonna okay, you guys coming with me? So I don't have to put fencing on that side, because they're not gonna go that way. Oh shit! You know, so they're gonna walk around. Does that make sense so far? So now if I have 80 feet of fencing, I don't have to go all the way around, do I? Then the question becomes, how long do I make these things to make the area the biggest? So I give my Wicked Witch of the West my, what's her name? That's Glenda's the good witch.
Yeah.
Elphaba, thank you. So I give all my Elphabas, all my variant Elphabas from different multi-universes, yes. So I give them enough room to roam so they don't get angry and zap me. I'm sorry, let me say this again. I want to know how long to make those sides so the area in the middle is the biggest. Right? It's not going to be a square this time, because I don't have a quadrilateral really. I just have this three-sided weird figure. Yes. Calculus will help me figure out what that arrangement will be. Yes. So this is just one example. So these kind of problems are called optimization problems. How do I maximize my profit? How do I minimize the electricity needed to do this? How do I maximize the number of puppies that I can help? How do I minimize the amount of hungry people? How do I, if I can set up an equation for it, I can then maximize and minimize. How do I maximize and minimize any function? We know how to do this shit. We just haven't done a word problem with it. How do I maximize a function? That gets the river and find the, set it to where 0 or undefined. Find the critical numbers, right? And then test those. Are you guys with me? So 4-7, we're gonna make our own function based on what they give us, and then we're gonna attack it with calculus. Alright. So I will, for those of you, if you go to the workshop, I kind of get into it a bit and I give some stuff out. So we're gonna do it in class also, yes? But the workshop's not a bad way to get a little preview. Alright. Yeah, we can leave it a little early. I've gotten on people's nerves more than normal today, so I'll let you guys out of here early. And then next time we'll just keep going. So we're on track. The next test is, actually, let me say this. Would anyone be upset if I made the test on the 29th instead of the 27th? Is everybody okay with that?
What's the downside?
Huh?
What's the downside?
I don't know. I don't know everything though, so why I wanted to ask. Oh yeah, our next quiz is going to be. So next week is the week of quizzes.
Oh.
Monday we'll have a quiz on. I don't know if I want to. Yeah, I'm not going to do a quiz on that. 4142. And then Wednesday we'll do a quiz on 4.3 and 4.4. 4.4 is the stuff
Can
we
we
did
do
today.
Wednesday and then the following Monday? Because I need a
No,
week.
because then the following Monday is review for the test.
Okay.
Yeah.
So I need a week more.
Everybody got it?
So the test is on the 29th.
Test, yeah, let me write that up there too. Am I recording? Yes. I'm gonna move the test to Wednesday, right? So a week after this. There we go. So next week is the walk. Next week is the walk. Week of quizzes.
By the way, almost all animals swim across water.
Of course they
except for hippos, hippopotamus,
Hippos walk across.
giraffes. No, they won't. And
Hippos are in the water all the time.
They'll walk on the bottom.
That's what I'm
They
saying.
won't-
They'll walk on the
but
bottom.
They won't swim.
So the fence would be needed for them. I'm talking about animals that don't go in the water at all.
It says